Let's take a look at intermolecular forces. So we'll start with a definition. Intermolecular forces are attractive forces between molecules. They are responsible for physical properties such as boiling point. The three kinds of intermolecular force we are going to look at are hydrogen bonding, dipole-dipole attractions, and van der Waals forces. Let's start with van der Waals forces. They're the weakest type of intermolecular force. All molecules have van der Waals forces between them, whether they're polar or non-polar. In non-polar molecules, they are the only type of intermolecular force. So, why is it that we have van der Waals forces? Well, basically, here we have a non-polar molecule and it has a temporary dipole. Now, in the video about polar molecules, we talk about a permanent dipole. This is not a permanent dipole, it's just a temporary dipole. And it's caused by electrons moving around within the atom. So at one point, the electrons might be on this side, which makes this side a little bit positive, and this side a little bit negative, and that can induce a dipole, a temporary dipole in another molecule. So we end up with a temporary dipole between molecules, which creates van der Waals forces. Molecules with larger molar masses have stronger van der Waals forces. So we'll have a look at the graph here, and we're talking about the alkanes. So alkanes with one carbon atom, 2, 3, 4, 5, 6. So one carbon atom would be CH4, 2 carbon atoms would be C2H6, 3 carbon atoms would be C3H8. So you can see that we are increasing the molar mass. The molar mass is increasing as we go down from methane to propane. So the number of carbon atoms means increasing molar mass. Okay. So what's the trend as we are increasing molar mass? Well, on the y-axis here we have temperature in Kelvin. So you can see that as we increase the molar mass, the boiling point increases. Okay. So boiling point increases as molar mass increases. So that means stronger van der Waals forces. Okay, so another way you could say it is as molar mass increases, the van der Waals forces between the molecules get stronger, so we end up with a higher boiling point. Okay, next is dipole-dipole attractions. So dipole-dipole attractions occur between polar molecules. Polar molecules have a permanent dipole. Now I've got in brackets here, in addition to van der Waals forces. Okay, so remember that polar molecules, they have dipole-dipole attractions and van der Waals forces too. Dipole-dipole attractions are stronger than van der Waals forces. Example, HCl. HCl has a permanent dipole. The hydrogen is a little bit positive, the chlorine is a little bit negative, and there's this dipole-dipole attraction here between the chlorine and the hydrogen. Next is hydrogen bonding. Hydrogen bonding is a special kind of permanent dipole-dipole attraction. You could say it's an electrostatic attraction between molecules. It's the strongest kind of intermolecular force. Hydrogen bonding occurs where you have a hydrogen bonded to an oxygen, or a hydrogen bonded to a nitrogen atom, or a hydrogen bonded to a fluorine atom. The example is water. Okay, so water, there's a hydrogen bond between the oxygen and the hydrogen atom here. Okay, so if you draw hydrogen bonds, this is how you draw them. It's like a dashed line like this, and we can draw that to another water molecule. Now actually, I'll show you over here. Water has 2 lone pairs on the oxygen, so that means it can form 2 hydrogen bonds. That's the reason why water has such a high boiling point, is each molecule is able to form 2 hydrogen bonds. Okay? So it's the reason why water has such a high boiling point is because it is able to form hydrogen bonds between molecules. Okay, let's take a look at this graph. This graph shows nicely the effect that hydrogen bonding has on the boiling point. So boiling point here, and we start with water. Now we have a high boiling point for water, about 100 degrees. If we go down to hydrogen sulfide, well, that's negative 60. Okay, the boiling point is negative 60 degrees. Why is it such a big difference here? Well, the reason is water can form hydrogen bonds between molecules, which gives it a much higher boiling point. Next, let's compare hydrogen fluoride and the yellow dot you can see here, which is hydrogen chloride. Again, hydrogen fluoride has a much higher boiling point because you have a hydrogen bonded to a fluorine atom, which gives you hydrogen bonding. And we can compare ammonia and pH 3, which is down here. Ammonia has a higher boiling point because it has a nitrogen bonded to a hydrogen atom, which gives us hydrogen bonding again. Okay? And one more thing, this line here with the red squares, we go from CH4 to SiH4 to GeH4 to SnH4. These are all non-polar molecules, and the reason we're seeing this increase in boiling point is because the molar mass is increasing as we go up the line. Okay.